Let us consider the next function, and for example, 1b. I'm going to be filling out this table of values right here for this. So I need to calculate my y-coordinate for a given x. And the table of values that I have been given include the x's that have the domain -3 to 3. So I'm going to start off and pick them off. For instance, if x is equal to -3, what is y? I'm going to calculate that. If x is -2, what is y? If x is equal to -1, what is y? So this area here is called the table of values. And table of values, really important. In fact, I think of it as the most important way to graph a line. If you don't know what's going on, use the table of values. So here's my preliminary work. When x is -3, what we have is I plug in, we have the equation y is equal to 2x squared minus 5. I simply plug in -3 and I calculate this through. I get a y value of 13. So I have to remember that has a point, -3, 13. Now here, when x is -2, I plug this into the formula, I get a y value of 3. So this turns into, or this means I have a point at -2, 3. Here, when x is -1, I get a y value of -3. So I have another point at -1, 3. Now, this is a really important point for a number of reasons. Number one, it's really easy to calculate. If x is equal to 0, by far, that's the easiest to calculate. 2 times 0 squared is 0, minus 5 is minus 5, -5. So this has point 0, -5. I'm just going to go into my table. I'm going to fill in those values, and hopefully I can get them straight, remember them. So this was 3, this was -3, this was -5. And you can calculate the rest of these by yourself. So if you want to hit pause and calculate those, I'll leave it to you. All right, so here, these are the values that I get. Should be able to construct coordinates given the equation and the x value. In fact, that's what I've just done. If I graph this, I'll start off -3, 13. So here's -3. I go y is 13. In fact, that's off the graph, so I'm not going to graph that. -2, 3. So -2, 3 is a point. -1, -3. So -1, -3. 0, 5. And then we end up with 1, -3. 2, 3, and that's what we have. What we can see is this is not a function. You may not be familiar with this, but we can see, it is a function, but it's not a linear function. That is, if I was to connect the dots in any meaningful way, if it was continuous, it would look like that. And in fact, this is a grade 11 function called a parabola. Now, we can take a look. What gave it away that it's not a parabola? That it's not a linear function? Well, it doesn't create a line. Reason number one. Reason number two, as x increases by 1, the y increased by, or decreased in this first example by -10, and then it decreased by -6, and then it decreased by -2, and then it increased by 2, and then it increased by 6, and then it increased by 10. So the change in the y isn't constant. So that's how we can tell by the table of values. From the equation, I can tell because the degree of the equation. Now, the degree of the equation just simply means the largest exponent. And what we may notice here is that the largest exponent in my equation is 2. So that's how I know that it's not a linear function. Did I have an exponent of 2 there? Not a linear function.